Okay, so I hope you are well, and also that you have all received my email, which contain useful links from our first webinar, which is part one that we did on Tuesday. Today, we will continue to build the project that we started in part one. Just to remind you, I am George Fatal, and with me today, Christian Proto, my colleague. We will be your hosts to make this presentation. So I see that we are a bunch of people around in the room. So what the way we're going to do it? Uh, the way you're going to do it, I'm going to do the presentation, and you're going to raise your questions, and probably I'm going to be able to answer them by the end. I think Christian, my colleague, yeah, he has an emergency, so he'll be leaving. He will not be staying with us during the presentation. So I'm going to be your only host. So like if you wish, you can wait till the end of the presentation where you can raise your questions, and then I'm going to answer all the questions that you're raising and spend all the time with you to see if everything is okay. Okay, so as I said, today we're going to be continuing the system that we started in part one. So let me first put the full project for the people that were not with us on the first one, part one. By the way, recording of part one is available. So like I'm gonna by the end I'm gonna send you links to see part one and part two, which and so you won't be missing anything out of this webinar. So everybody will have all the links for the project and the recordings of part one and part two. So I'm going to start now. Let me, first of all, just clear up my PowerPoint presentation. And here we go. I'm in Automation Studio. So when we started this webinar, the purpose was to build in two parts a system and then this is basically what we build. That this is the entire project. So I'm gonna put it in simulation mode to show you what it's all about. So basically, we are having here a simple hydraulic system. Let me just zoom in a little bit. Yeah, where we have in this hydraulic systems, we are having a sequence where let's see the sequence. So we're going to start the electrical power circuit. Then we're going to start the system. So we see here there is a pump starting, and then we're going to start the sequence. And basically what it is, it's hydraulic system, which is once it reaches the end of stroke of the hydraulic cylinder, it will activate a solenoid on the pneumatic system to push a box on a conveyor side or in a so that this is as a mini process. And then here I'm integrating hydraulic with pneumatic library. And then the logic is done using a PLC. In part one, we did the logic using relay logic, and we converted the logic into ladder PLC. So here we have, I'm using a compact logic PLC. And on the electrical side, we have an electrical three-phase electrical circuit activating a motor, and the motor is used to drive the pump in the hydraulic system. So this is basically the entire project that we were building in this part one and part two. So I'll show you part one. Part one, we did partially part of the system, and we stopped where at the sequence, and then I can show you part one. I'm gonna grab the project that we built together in part one. So let me stop this one here and start with the project we did in part one. So I'm gonna go to the webinar here, and then this is the project that we built together in part 1. So you see over here, if I start again the sequence, we stopped at the sequence where we are starting the sequence. So we have the hydraulic system, and we did the logic to make this part works. Now we have to complete with electrical three-phase system where electrotechnical diagram for the motor that drives this pump, and also add to it the animation of the box running on this side of the system, on the pneumatic system. So let's start building our electrical diagram. So first thing, we're gonna, like we did in the system, we want to start selecting the hardware that we're going to use in our electrical diagram. So we said that we're going to build a HMI for the system. So let me first add component from the HMI library. Well, we can recycle some of these over here by copying them. So basically I need a button, so a push button. So I'm going to make a copy of the push button. To make a copy is very simple. Like we said, it's just like you select the component, you hold down the control button in your keyboard and you drag. And this is a copy of the start push button. Now I have to reconfigure this one to matches my request here. So this one, I'm still going to call it, well, just to make differentiated. So I'm going to make it, call it start motor push button. Now, to make sure that it's clean, first let's see if it's hooked to anything. No, it's like it's not linked to any electrical component yet, so that's fine with me. That's what I want. Now I'm gonna change the color for it. I'm gonna give it the color green, for example. Now I'm gonna use another copy of the button here, which is gonna be the stop motor push button. Now this one, we're going to change it to yellow. And then what we need to complete the controls over here, we need lights. So we're going to have, take from the control on signaling device, I'm going to select a pilot light. I'm going to take here this pilot light. By the way, this light, if you remember, it was a flickering light. It was like going on and off. This is not the kind of light I want to use for the electrical section, for the electrical controls. So I'm going to use just a steady pilot light. So this one, I'm going to use this one. So this one is going to be used for the purpose of showing that the electric circuit has been engaged. So this one, I'm going to, first of all, I'm going to just give it the same size as the button, and like I showed you last time how to do it, you select the component that you want to make to use as a reference, and then once you select it, you're going to handles here are turning to blue, and then I'm pushing down the shift button to the bottom, and then selecting the other component. So this is the one I want to relate to this one. So here on the edit ribbon, I go to sizing, and then I can change width and height. So this way I scaled the lights to make it identical to the push button. So I'm going to just put it somewhere here. And then I need another one. I made a copy, and then this one, I'm going to use it for overload alarm on the electric motor. So I'm going to give it a color red. And then from there, I can just put there, like, by the way, just to get some space around here. So I'm going to move everything, take it more room at the bottom here. Now the next thing is I need a disconnect button. So I'm gonna go here at the same section of control, select on the switches, disconnect switches. I'm gonna pick up a disconnect. I'm gonna take this one. This one is huge. So, but anyway, I'm gonna adjust the size, disconnect. So this one will shrink it. Here, we'll shrink it in size. Let's say this is what I want to be. Okay, this is my disconnect. Here, I'm gonna just like, now let's start doing some alignment for this component together. So I want to align these buttons together. So basically I'm gonna just select them. And then on the edit, on the alignment, I'm gonna align in the middle, the buttons. So here they are aligned. Now maybe I'm gonna just bring this one a little bit down here and move the text for disconnect, bring it on top of the button here. Now let me take off the question marks. I don't need them here. So this is my HMI. This is my control box for the electrical circuit, three-phase, the AC circuit. Now, from there, we need to start associating these buttons to electrical components. So let's move into the electrotechnical library. We use NEMA as a standard. Now, I want you to see here what's going to happen. Now, here, and this is frequent for you guys when you do building a project, you'll come to build electrotechnical diagram, and then you're going to start getting some components. So I need some contacts. So if I go and select relay contacts, you see here, I need a normally open button here. So you see here immediately that this button I cannot bring into the standard diagram. The reason is that Automation Studio, because we have multi-technology libraries that can be used, not all the diagram that we use in a project can accommodate the symbols or the components that we drag from the different libraries. So here, once we started this project, we started with a template using a standard diagram. And just to remind you, if I open here the Project Explorer, so you see in the Project Explorer, we have this diagram, which we have our drawing, is a standard diagram. And in the standard diagram, I cannot put component from the electrotechnical library. So what I need to do, I need to add another document, electrotechnical diagram document, that will accept these symbols and continue building my electrical circuit. So I'm going to create one. I'm going to pick the default one. Now, once I have it here, you see, I see it here, it has been added. And to be able to work on both of them, I go into the view ribbon and split the project into vertical tiles. So here I can just close this one to get some space. Let me move this diagram here, this one, and move it there. Here in this side, I'm gonna just like come to this section. This is what I'm working on now. And here I'm gonna expand it to get some space and a room over here. Now I can just adjust the panning for this document here. I'm gonna do it like that. And let's continue. So here we said that we need an auxiliary contact. So the auxiliary contact, I'm gonna bring over here. And immediately when I grab the auxiliary contact, it asks me, it relates to which components. So this contact will relate to the start motor push button. So I'm gonna tie it right away. So I come over here. In this window, I'm gonna put a filter for the start motor push button. So this is the motor. This is the motor, the button I want to relate it to. So I double click. So now it's related. It's hooked or connected to the start motor push button. Now I'm going to need another button here, which is this is normally open. This one is normally closed. I need it for the stop motor push button, and in the stop, I'm going to just stop motor push button, just tie it up. Now this button is related to this electrical component. Now the next one is for the lights. We have two lights over here. So we need from the DML library on the signaling devices here, we need the pilot light. So I need two pilot lights. So one pilot light I'm going to use for the on, or the system is on, and the other one I'm going to use for the overload fault that I'm going to create on the motor. So to be able to relate these two buttons to these two components, here, if I double click, internal link, well, when I see over here, because this button has not been identified, to be able to locate them and to do the tying in over here with the HMI component, we're going to use their internal ID. So to show the internal ID of these two lights, I'm going to select the two lights here. These are selected. And then if I double click, you see here that I can display the internal ID. I just click over here, internal ID. So here you'll see that their internal ID are now displayed. Now let's start. This button, I'm going to make it like give it related to the on circuit. So you see here its color is green. So before moving, I'm going to change the color of the button to green. And this one is related to the faults, red. So here it's in red already. So we are okay. So now we're going to start tying them together. So I'm going to select the first button here, the first light, then internal links, and I go component links. And you see over here that this is ET3. So I select this is the light and then link it. So this is done. Now we select the next one. So the next one is here, link, component link, select ET42, ET42, this is the one, then link. Now everything on this side is connected. We still have the disconnect that we have to link it to a component that we'll grab later. Now, so let's start building our three-phase circuit. So what we'll do first, we'll need a power source. So the power source is a three-phase. We need energy source. We're going to need a three-phase source. We're going to take one with a neutral. So we're going to have this one. This is my source. Now the next part is going to be a protection. So in the protection section, we'll take the fuse, for example, here. Now the fuse, I'm going to call this one disconnect, right? And this fuse is the one that's going to be connected, tied into this fuse. So it's about time to tie them together just to get rid of this relation. So we do here, select the fuse. And then what we're going to do, this is the state, which is the active device. We'll take it from the disconnect component. This is the disconnect component. So now I did tie these two together. Now let's continue. So we need, in the protection side, I'm going to take here an overload, thermal relays. So here I'm going to take this one. I'm going to call it overload, right? And then we're going to go and start adding other components. So we probably need to do the controls a transformer. So we need a transformer. And then we need a relay. You need a relay, control relay coil. We need one over here just to start the motor. So this is, I'm going to call it control relay forward, right? And we need on the some contacts. So I'm going to make here, this is a holding contact that I'll need to hold the contact on the start. So this contact is related to this control relay. So to establish a link between the two, so I get here control forward. So here it is. So now this one is related. Now, before continuing here, let's move on and add for the contacting of the motor, 3 contacts for the starter. And this one too will have to relate it to this control relay. So here, double click on it. And then on the variable assignment part, I'm going to just do the association. So now this is associated with this one. Now we're almost done. Now we got an overload here. The overload, we need an overload contact to cut the contact on the control relay. If I'm going to go in a overload situation. So here, what we're going to do here, I'm going to close the power, take the control section, and then you're going to see on the relay contacts, you're going to come over here somewhere. Yeah, and we're going to need 2 of them. One, we're going to use it for turning on the light of the alarm. And this one is related to the overload. So here it's related to the overload. And we need this one normally closed, normally open, sorry. Normally closed anyway. So I'm going to need it for the overload here, just to break the contact on this relay. Now I've got, yeah, what is missing? Yeah, I'm missing mainly the motor. The motor I'm going to take from the root of the library here, electrotechnical NEMA. I'm going to get my motor out of there. So I'm going to need a 3-phase motor. I'm going to take this asynchronous motor here. Now in this motor, I don't need to display everything over here. I'm going to just take off the output torque, variable load. I'm going to take it out. I'm going to just take the angular speed. Yeah, now displaying this, I want to display also for the overload. I'm going to display the tripping countdown. So tripping countdown. So I'm going to display it, select it, and then what's it going to do? It's displayed here. Now I'm going to bring it to the drawing and double click. I can just like increase the size and then make it bold. Yeah, now it's in a format that I can watch and follow while I'm doing my simulation. Okay, so I've got everything now. Now let's start connecting all the parts together. So I go over here, and then you'll see that in the Home tab or Home ribbon, when I'm selecting the electrotechnical diagram, I see here a section for the wires. So I'm going to take the polyphase wire. Polyphase wire enables me to connect the 3-phase in one shot. So here I can just like connect like that. Me take it. Here I'm connecting everything together in the 3-phase circuit. Now I connected the 3-phase circuit. Now if I go change wire, take let's say power wire, I can connect my transformer. And then I change to a command wire. I can start stringing up my control circuit. So for the control circuit, let me move these things a little bit around here, like that. And I'm gonna start stringing my wires. So I'm gonna start here to, this is my stop button. This is the start here, here, and then here. I'm gonna come back here. Now, what we do here, we just like, this is the holding contact here. Now, let's start with the alarm first. So sorry, let me select this part here. I'm gonna go here, put it there. And for the alarm, we're gonna just like go like that here. And then this is the on light here. Now what we can do is we can just take off this because we don't need it here anymore. So I'm having here my circuit. Okay, I'm still missing the neutral wiring, so I'm gonna select a neutral or ground. So I'm gonna put here a ground, make a copy for a ground, and then having my ground, and now taking my neutral wire. So I'm gonna connect here, there, and there. So this is my electrical circuit. Now let's start. Okay, still missing this part. So I'm gonna, this is the neutral wire. So I'm gonna take it here. So we can start testing now. Before starting testing, let's validate the circuit. So we see here we have a 208 volt power supply or source. Let's see the motor. The motor is running, it's a 480 volt. So let's put it to the right voltage, 208 volt. Now on the transformer, we see on the primary voltage is 208, which is fine, and the secondary is 120, which is fine. That's good. Now on this relay, we see that the rated voltage is 120, operating voltage 115 and 100, which makes it all right too. So we are ready now. So first, let's start testing the circuit. So first thing, we push the disconnect. So disconnect, we are putting the power into the system. We got the red light, the green light. The power is on, which is right. Now if I start, so you see I'm starting, I'm maintaining contact, the circuit is working, my pump is working, everything is fine. Now if I stop, everything is fine. Now what I can do over here to make it stop faster, I can add more torque here just to give it some resistance and close. Now, the rating on the overload, for example, let's see the rating on the overload, if it's okay. So first, let's start it again. Yeah, before starting in simulation, let me read some current. So I'm gonna measure a current here at this part. So let's see. So I'm gonna use the RMS current, and this is what I want to do. Let me put like that, reading. And let's start the circuit. So you see here it goes 52 and goes down to 16. This is an inrush. So this one over here, like what you see here is like, I can start putting some load. You see the current grows, and then this one goes 43. Let's see first, let's test to see if this part of the logic work for shutting down or cutting the power on the control relay. So I'm gonna first come to the overload and go on the builder section of it. And then this one is rated 30 amps. Let me put it at 10 amps. I know that I want to make it trip faster. So 10 amps, so we can do it like that. Then put it back to simulation and then put the disconnect on, start the motor. Now it's 52, yeah, here, go, boom. So the overload, engage. Now I lost here, like I see that I got the alarm and I'm getting the disconnection, like the forcing on the signal coming to the starter of the motor. So that's fine. That's okay. So this part is working. Now what we do here, let's put it to 30 the way it was. It was okay. So basically that's it for what we did over for the electrical circuit. Now in the original project, you notice that this circuit was hanging and sitting somewhere over here. Like if I put it here, it was displaying over here. So to do that, we can do it very simple. What we have in version 6.4, you can come over to the home ribbon. Let's say I'm going to take the electrotechnical, point to the electrotechnical drawing, and take the home ribbon for this drawing. And you see here a document view, a documentation document view. So if I select document view, you see the shape of my cursor has changed. And here I'm selecting the section of the circuit that I want to display on the other drawing. So I'm going to do that. You see here, it's not. So here I'm going to do that. So I selected this drawing and now I'm going to display over here where I want it to be displayed. And here how you do it. So it is going to be displayed here. Now a little detail, like when I did my selection, you notice here that I don't have the 2. It was being cut because I cut it through the 2. So what I can do, I can just like delete it and start over again. Here. So I'm going to start again, select here electrotechnical, home ribbon, document view, take the document view, come something like more toward, no, it's still no good. I have to start over. Let me bring, yeah, I can just go like that, doesn't matter. So here, document view, can come over here. Yeah, now it's better. Can select enough of what I want to show. And I come over here. And here you go. Now, you see, I show everything, which is good enough for me. Okay. So now what we can do, conveniently, we can just close this one over here and then put the focus on this drawing and see now my project. So here, let's start it. So let's see. Yeah, okay. Yeah, I'm missing one part. I'm still one more step and I'm done. So the next step here I'm missing here is I want to tie in this motor to the motor, the pump over here. You see this pump is continuously running. I want to change this type of pump to make it motor driven. So I'm gonna take it out, go there, stop, take it out. Now in the hydraulic side here on the pumps, I'm gonna take a fixed displacement pump, but with a shaft. And here I'm gonna select from the driving section here, the power unit. So I'm going to take an electric motor and I'm going to put it to drive my pump. Now this motor, I have to relate it to the motor over there, this one. So to relate them together, let me get back to my drawing. So I need to go to the electrotechnical diagram here. So what you see, let me put them again in view, vertical tile here. So this motor, if I double click on it, you'll see that they're going to be tied with the angular speed. You know, like I want to translate the angular speed on this motor to the other motor, which is over there. You see here. Where? Here. So this motor here in the variable assignment section, I can send to it the electrotechnical receiver, the input signal, which is the signal of the angular speed. This is the variable I want to tie it to. So to do the tie-in between the two, the easiest way of doing it is to use the internal ID of the motor. So I'm going to select the motor and then go to the, where is it? Yeah, here it is, the internal ID. It's ET12.2. Let's display it. So this is the angular speed here, ET12.2. I come over here, go to variable assignment, select the variable, and then in here to display the variable related to my ET12.2, I'm going to go select the location, select filter by location, and then here I should find the component which has this internal identifier. So you see here, internal identifier, this is in the electrotechnical diagram. So this part I can skip over fast. And then once I'm going to hit electrotechnical, I can just go slowly here. Now electrotechnical, once I'm hitting, I have to select ET12.2. ET12.2 is this part, this is the component. So once I select it over here, I got the filter, just show me the variable related to the motor. And so here I need the angular speed. So the angular speed, I tie it into electrotechnical receiver. I just double click now. Well, okay, double click. He catched it here. So now they're tied in together. Now before moving, I want to display it. So I'm going to display the radial speed on the drawing. So I just go in the data section, select on radial speed here, and you'll see it here. It's going to be here. This is radial speed. Now let's start. Now let's see, simulate the circuit and see how what's going to happen. So here first, let's start doing simulation mode. I'm going to turn on the disconnect, then I'm going to start the motor. You see here it's starting. Now it is, yeah, just like, can give it a release here. So it's going to get 1735 RPM. Let's see, I go over here, you're going to see 1734, which is fine. The value is fine. Now it's working. Now if I stop here, here you see that this one stops too. Now I'm going to start, and then I can start my sequence. So by starting my sequence, the cycle, so you see here, everything is moving. So I did this part now. Now let's stop the simulation. Let's get back to my project here. close this one. I need some space, and go there and start. Now the final touch I want to do here is to build to this one a box. So here, what we're going to do to make it like a control box for these buttons, very simple. Just go to the home, rectangle here, build a rectangle around them. Here. Now I'm going to fill it with color. So I'm going to just make it filled with totally solid pattern. So it's black. Now it's coming on top of the buttons. I want to put it in the background. So I just connect to the button here on the layout, put it on the background. Now this is not the color I want. I'm going to change the color to something, a light blue color. So now I'm having my control box. Now the control box, I have the flexibility to move it around the drawing. So I'm going to, let's say, realign my drawing. So basically what I'm going to do, I'm going to take this one here, move it, for example, here a little bit, like that. Or let's say move it like that here. And take the box here, put it here. Now we're done with the electrical drawing. Now let's start doing the animation part, which is the box moving back and forth here. So this is interesting because a lot of people ask a lot of time how to do this kind of animation. So I'm going to show you in details, I'm going to work it out completely and show you what it takes to do this kind of animation. So first of all, let me increase just to make it clear here. I need some room to see this, right? I have more space here. Now, allow me to put a section where I'm going to be writing stuff like in a blackboard. So I'm going to open a notepad document here. Let me reduce it like that. And then let me take this drawing, put it there. So now I'm having, I'm going to work here on a notepad. You're going to see why. And I'm going to come over here. So first thing in the animation, I have to define exactly what I want to do. So basically, I want to move a box. I have a box here that we're going to drop. And then when it's going to be at the level of this piston, I'm going to have the piston in the sequence. You're going to start pushing this box toward the end of stroke of this pneumatic cylinder. So basically, I'm going to start pushing the box when this cylinder is at 20%. So first of all, let's say at 20%, where? So I'm going to do this one, move the cylinder to 20% position. So I'm going to move the cylinder to 20% position. So it's going to be like that. So this is, I open at 20%. Now what's going to happen here? I need to put there something like a piston or let's say something, a punch to punch the box. So what I'm going to do here first, I'm going to draw here a box here, a rectangle, which I'm going to shape. Let me do it here. I'm going to shape it as a shape of a punch. Okay, the punch. Now what I'm going to do here, I'm going to, let's say it's going to be sticking to this cylinder. So you see over here, when I'm moving with a step of one grid. This is the snapping. Now to control my snapping here, and this is going to be very important to understand this concept here, is you're going to see that at the home ribbon, there is the snap section. There's two types of snap. The first one is the component snap. Component snap relates to the components, which are these components. Now the drawing snap is related to these objects, to anything that is in this section. The snapping is done using this kind of snap. So you see both of them are by default snapping to the grid. Now I'm going to relax this one a little bit. So if I click on it, you see that this is the different kind of snaps. This is 1/20 size of the grid. This is the, so if I pick this one and just start moving it as is, I'm moving it very swiftly over here. So I'm going to, let's say, move it there or move it here. Now let me move close to my grid here. So that's basically good enough for me. Now the next thing over here, I need to get the coordinates of this object on the drawing. So to get the coordinates on any object on the drawing in Automation Studio, you select the object and then you right click. So you're going to see here a dialog which is coordinate and orientation that you can open it. So once I do it like that, you see over here is give me the coordinates of this object. And then what you see over here, the X coordinate, the Y coordinate. X and Y in Automation Studio, the origin of any document is this corner, the top left corner. And then you see that the X direction, this is 0, 0 coordinates. X increases toward the right and Y increases toward the bottom. So anything, the positive axis for the Y is going to the bottom. So for me, I really need this the coordinates because it helped me to position this component more accurately than moving them with the mouse on the drawing. So first of all, because this snapping, I don't like it's 120. Let's want to snap to the grid. I want to see the grid where it is. Yeah, you see that for the grid to be aligned properly to the grid, the Y position, because I want to make it straight, running straightly on this line, is 2.2 centimeter. Now I want to make it in millimeter to make it more accurate, 278 millimeters. So I'm going to be working everything in millimeters. Now let's get back to the 120s here. So I'm going to come here, say here, this is my starting position. So let me put here, I need, this is position, this one I'm going to call the piston. I'm going to put it here on the board. I'm going to say there's a section where I'm going to pick the coordinate for the piston and the another section which is the box. I'm going to do it for the box too. So this position is the 20%, I'm going to call 20% position, right? Now, the coordinates of this position here, I'm going to pick the X and the Y. So X equal 276.2 and Y equal 22. Now, this is the position where my piston gonna come. Now I need a box. The box gonna come over here. We're gonna draw a box. So the box will come here. So first of all, let me draw the box. Want to snap it, doing a good box. I'm gonna do it properly to snap to the grid. So I'm gonna do it here. So this is a square box. This is good enough with me. Now, once I do that, let me take off the snapping here and then to 120 and then align it over here. So I can just maybe give it a touch like that. So that's the starting position. So for me, let's say I'm going to say that for the box, this is the 0 position. So I'm going to say that this is position 0, and it has an X and a Y. So let's see what are the X and the Y for this position. So I select the object. So the X position is 278.2 and the Y position is 22. Notice that because these two are aligned, they're carrying the same Y coordinates, Y22, which is all right. So this is position number 0. Now, what I want to do now, I'm saying that starting from position 20%, the cylinder will move 100%. So I'm going to come over here. I want it at the position 100% here. I want to have my piston will move here and the box will move with it. So what we're going to do, we're going to take this one. Let's start with, oops, I'm going to do Control Z to put it back where it was. Now let me move it back over here. So you see, let's say here. So is this all right? Yes, it's all right. Now in this position, what you'll see over here, by the way, to align it, what's beautiful about this coordinate orientation, I can adjust it, make it 22. So now I know it's perfectly aligned with this one. But with respect to the X position is good for me. So the X position is 297 millimeter. So here, I'm going to take this one here. I'm going to copy, bring it down here. V, say that the 100% position, it relates to 297 millimeter, right? Now I'm going to need the 0 position for this one, so I'm going to do it the right way. Now I'm going to do it here, Control V. I need to pick the coordinate for the 0 position. We'll do it later on. Now, the box, I'm going to say that the position 1, the box will be punched. So basically, I need to collect the box, and I'm going to pick it. I'm going to bring it over here. So I need to align it a little bit because to stick it here, give it an arrow. So that's the position of the box at 100% position. Now, what are the coordinates here? I select the box. C22, the alignment is all right. And I see the X is 299. So the position 1, it's 299 and 22. Right? Now, let's finally, what I'm going to do here, I'm going to bring my cylinder to 0 position again. So 0 is here. I'm going to take this one, get the coordinates, Control Z, sorry, I'm going to bring it. Now I'm going to just take it. And this is the position 0. Yeah, that's good enough for me. So here, I'm going to say it's 22 for the X, for the Y, sorry. Now for the X, it's 271.1. So 0 is 22, and here it's going to be 271.1. Okay. Now let me get back the box to its position 0. So box position 0, I have to change it to 78 to 78.2, right? Now what's going to happen? The box is here, and it will come top down. Let's say I'm going to take it from here. I'm going to take it, let's say, all the way here. So very important. My X position has to be, to start at the right position, I have to adjust this one to 278.2. Now, for this position, I need the Y coordinates. The Y coordinates is 0.1. So this position, I'm going to call position -1. Position -1. And it's 272.2. sorry. Yeah. Sorry. This one is. Wait a second. Here, the X has to be. No, it's 22. Excuse me. Let me see again. Here, it's going to be. Here in this position, the X 272.2. Sorry, yeah, it has to be 272.2 because it starts here. And the Y should be at 0.1. So that's basically my position 1. Now, once I know exactly the coordinates of everything now I can start define how it's going to be the translator. So let's going to start. The easiest one is going to be this object, this rectangle. So let's start with this one. We're going to associate with it its translation. So this one is very simple. It's going to move horizontally, and it's going to move. What is the translation that has to do? So for the piston, let's define here what we're going to call the X translation. And we'll define what it is going to be, which is basically, if we associate here the translation, it's going to start from 0. And what is the maximum that it will go? The maximum that it will go is going to be from, I'm going to calculate it. It's 297. This is, the position is 297 minus 271.1 minus 271.1 equal to 25.9 millimeter. So we're going to call it here. Put it, this is 25.9 millimeter. And this is the value that I'm going to use over here, put 25.9 millimeter. Now the 25 millimeter, once we're defining here my translation, it relates to another variable that changes in the process in the system that will make this object to move from 0 to 25 millimeters. So what is the object that we're going to be using to make this object move? It's definitely, first thing in mind is, let's say I'm going to save the change, yes. It's going to be out of the cylinder. If we see in the variable in the cylinder, we see that it has a variable called output signal position. And this output signal position, if I want to see, it's what is the value that is generated when the cylinder is moving. I can see it out of the builder. You see here if there is a position sensor, and it shows you that this variable will change from 0 to 10. This is basically what I need as information. So I come over here, back to this object again. In the translation, the value will correspond to a change from 0 to 10. And then here, I have to create a variable that will change from 0 to 10 so that I associate with this variable. This is a translation variable used for configuration of the translation of this object. So I'm going to create a variable. By the way, creating the variable, this variable, very important, it has to be type real. So I'm going to create a variable, which I'm going to call the X position. Here. And this variable, I'm going to relate it. I'm going to define with it the horizontal translation. So this is the variable. If I put here my filter with the name X dash underscore, so X position. So here, double click. So now the translation for this rectangle is defined and is configured. Now, before moving from here, the value for X position, we have to say to see how we're going to give the value, change the value of X position. So it will be related, the value will be related to output signal position. So here I have to tie in the variable output signal position to the variable I just created. So here, I'm going to come back again to the name. And here I'm going to say X. Yeah, X, start with X. So this is the output position, X position. Just double click on it. So now the output signal position of the cylinder will go to the variable that I define X positions. Okay. Now that is done, we can right away, if we want, we can test, see if everything is working fine. So I can just run it and then I can hear force. Okay. Yeah, there's something. Let's see what I did wrong over here. So here in the translation, 0 to 10. And this is 25.9 millimeter. Up. Yeah, let me see here what's going on. I'm gonna run it here again. Oh, wonder it was. Let me see, I want to see something else. I want to see directly on the variable manager. If I go to the variable itself, name, I want to see X position, X. Let me see here the variable. Let's see if I do X underscore. Yeah, here's the variable. Oh, see right away that I'm having a problem here is that, yeah, the reason is my X position is a Boolean variable. So probably that's the reason why I'm not successful. I told you it has to be L real, so I'll have to delete it here. Yes. And I'm going to create it again. So I'm going to create the variable. It has to be type L real. So here, so that was the problem. X position here. So it's type real. Now what we're going to do, we're going to come over here first to X position, reassign it again, type here, and we come back here and we'll, on the variable assignment, output signal position with X position, I will type back here. Now if I test, we see here, now we're talking. So now you see the translation of this moves with the cylinder the way I want it. Now, next thing, let's work out the translations for the box. The box here, I'm going to assign it a translation. Now, the box here, I'm having two translations. I have a translation in the X direction, which is going to be moving with the cylinder, and another one vertically, which we'll have to define. So we have to define both translations. So I'm having a Y translation, an X translation first, and a Y translation. Now let's see what are these translations, what are their values. So let me open my calculator again. Here, come here. Now for the box, the X translation, I'm going to be moving from the position 0 to the position 299. So it's 299 minus 278.2. It's equal to 20.8 on the X direction, 0.8. And in the Y direction, which is going to be, I'm going to start at 0.1 and go to 22. So it's going to be 22 minus 0.1 is going to be 21.9. Okay, millimeter. Now, very simple, we're going to come over here. We said horizontal, which is the X, is 20.8. 20.8. And here is going to be 21.9. Now, we know that this one will be moving with the variable X position, because this variable that moves this object is going to be the same variable that moves the box on the X direction. So we know that the variable here will change. Now, the tweak over here is that I know that when the cylinder one is going to be maximum is going to be 10, but here the box is not starting from the same position as this one. It starts when the cylinder is at the 20% position, which the starting value here is 2. So I have to start when the value is 2, it's going to be 0. When the value is 10, it's going to be 20.8. So this is what I have to see that for this specific object. Now, for this one here, because this is really, we don't have something like to move vertically, we have to simulate it. So we're gonna simulate it. We have the flexibility to pick any value that we're gonna change from 0 to 21.9. So what I'm gonna do, I'm gonna make a variable change by programming to 0 to 29. And I'm going to show you how we're going to do this in the programming. And I'm going to name, now it comes to the part where I'm going to relate the variables. So this is in the X direction, we said it's going to be the X position here. This is the one. It's already in the filter. Now in the Y offsets, the Y, I'm going to name a variable which I'm going to call the Y position variable. Don't forget that this variable has to be real. Last time I did a mistake, like when I defined it as Boolean. So here it's real, so the definition is right. And then here I'm gonna tie it, the Y position to the Y offset. So here I did the definition like that. Now we can test one more time to see if everything is working fine here. So if I test here, if I force, you see that here it goes. So in the X direction, it's working fine. Now I have to find a way to bring this box down to this position, okay? This one, to do it, we're gonna do it using an SFC chart, a graph set. So SFC, we're gonna come over here. We have to create an SFC program. So we're gonna create a sequential function chart. So we're gonna create one here. And let me do it now. Let me see here. Now let me see. I'm going to open this one. I can, and then here on the tools, let me show my diagram and the SFC. Yeah, I'm gonna have to do a view, a vertical view. So I'm going to have everything over here. So this is the SFC part. This is my program part here. And let me write my SFC here. I'm going to pan it here. Is there a way to zoom? Yeah, I'm going to zoom a little bit, zoom like this. Okay, so in the SFC, what we're going to do, we said we have a variable called Y position that we would like to, Here, we're going to do it like that. We're going to say the Y position. We have to program it and modify it so that it increments in a certain way to bring the box from this position to the bottom. So we're going to do this. If we go on the SFC chart here on the home ribbon, this is going to be done with a structure text. So we're going to take a structure text instruction. So I click on it, and then in the structure text, this executes like this. We're going to do an equation which is going to be like defining the Y position. So here to write it down, we got some tools in the graph set which enables us to write these kind of equations without doing typos. So I'm going to first select here insert name. I want the name of the variable and not the alias of the variable because the name is more precise for me. The alias, I recommend using names while we're working with SFC. So names, I have a variable called Y position. So if I put here Y, this is the variable I'm going to say Y position, and then the equation is equal Y position again plus something, plus something. The something that I'm going to add here, it's a new variable that I'm going to add, and this what I'm going to call the Y speed. It's a constant, but I'm going to define in a variable called Y speed here, and then we're going to give it a value which is a constant value. Now, this is how I'm going to increment my position. But now there is a condition. If I just run it like this, it will going to increment forever. So I have to know when I'm going to stop. So, or a condition to say when this equation will exist. So there is a construct in GraphSet called the if construct. So it's a statement here, an assignment statement, condition with an if. And my if here is related to the Y position variable. Again, I'm going to say that I'm going to increment as long as my value is less or equal what? The value of the translation. So let's say I have here again, here is my, open again my window here. The Y translation is value is 21.9. So as long as I did not reach the count of 21.9, I'm going to be incrementing. Now, that's true, but I have to take in consideration that the incrementing of the value has to start to be done only when I'm going to be, let me, if I go over in my drawing over here, save changes here. If I come over my diagram again here, let me zoom out and then goes. The incrementing will be done when I'm going to be, the two cylinders going to be at their start position. I have the position A0 and B0. So somehow I have to use a condition here to trap the position I0 and B0. So what I'm going to do here, I'm going to come back again to this structure text here, and I'm going to add two variables here, which I'm going to call IA0 This is a Boolean variable because it's a position, okay? And IB0, I'm going to create another one called IB0 here, and this. So basically, counting here or advancing the Y position is if I am at this position, that means I'm at the start position of my hydraulic and my pneumatic cylinder, and my position here, my counter here, the value of this is less than 21.9 because I'm going to start from 0. I'm going to count. When it's going to stop, when this value is going to be 21.9. So basically what I'm going to do here, now I have to get the value for these two positions. So I come over here, so I'm going to do it like that. Sorry. So I'm going to select this proximity sensor, and I'm going to tie the value, its state, to my two variable I just created. So I is 0, so this is A0. So here I'm going to tie it to I is 0, and this one, B0, is going to be tied here. So now the value of these two position sensors going to be brought back here to this sentence, to this structure text, okay? Now the next part is that I need also a pointer or a condition to tell me that the box has been is at its place. It's at the position. We said here that we defined a position called position 0. So I'm going to say create another structure text here. I'm going to open it. Oh, sorry. I'm going to create another one. So I'm going to delete one here. One of this structure text I'm going to delete. Now here, structure text 2. I'm going to create another variable which is called, we're going to call it in position 0. This is it's like in real life, the boxes usually you put a sensor like a photocell or a proximity sensor that once the box is located at the right position, it will trigger a 1 to tell you that the box it's in position, it's sitting in this position. So I'm creating here a variable for that, so in position 0. And then I'm going to say that in position 0, to simulate it, I'm going to say this is a Boolean. So I'm going to say it's 0 equals 0. I'm going to work the same technique that we did before. And we say if my Y position is what is less than what 21.9, I think, the value here of the translation, I'm incrementing to 21.9. So if it's less than 21.9, it's not in position. Now to go in the next line, I can just make another line here, and I can take this condition again, copy it here, and then make it here. It's going to be 1 when the position is greater or equal 21.9. So that's basically the way I'm going to know that the box is reach the right level. Okay. Now, since we did this in the graph set here, now if before starting, I have to complete this graph set by putting, like initializing my variable to at the startup of my program. So here I'm going to do here, create here. This is it's a step and transition, and then see what we go. So once I'm going to start my program, let's see what are the variable I want to deal with. First of all, I'm going to have the X position. So I'm going to say X, the X position. I'm going to make it equal to 0, I'm initializing it to 0. Now the Y position, I'm going to also make it equal to 0. Now the next one is the Y speed. This is what the Y speed here, where I'm going to be initializing the value of the Y speed to an increment, a constant I'm going to call 0.1, right? And then what are the other variable I defined in position? In position is I put in position 0. This one, look here, very important to notice here in the graph set, the assignments or of associating a value to a variable. If this variable is real, there is the equal sign, the assignment sign, and there is a space here. For a Boolean, it's going to be equal, and I have to, this is syntax, it has to be stuck to the equal, no spaces over here. If by any chance I put here a 0 space, you see right away the validation, there is a continuous validation of the syntax in the graph set that will show me that the instruction here is not green, it turns in red or in purple, which is mean that there is an error here. So the error is because this variable is a Boolean, and to initialize it, I have to give it a Boolean value. So this is the assignment way. In a Boolean, it's going to be either 1 or 0. So this is right, okay. If I want to force it to 1, this is 0. If I want to force 1, this is 0. If I want to force it to 0. So that's basically how you do it in a graph set. Now, basically, the other variable, IA0 and B0, I don't have to worry about them because these values will get the value out of the sensors, so I don't care. So, but I need to have this value initialized at this value when I'm starting my graph set. Okay? Now I did this part. Now the next things, let me move over here. Let me move here, this instruction here. Now the next things in a graph set, I want to define what is the initial step. The initial step is this one, so I select it, I right click on it and convert it to the initial step. This is the convention in graph set SFC. I have to define always an initial step. Now in the initial step, when the graph set will execute, it will start over here, but I don't want to make it stay stagnant over here because it needs a condition to move to the next step. If I need to put it stagnant over here, this value will always be forced to 0 all the time. I want it, as soon as I enter the program, it do the initialization and move on and stay here. I don't want anything changing this value other than these equations and the program. So what I need to do, I have to change the transition. I can force it to an always true condition. So always true condition, if I double click on it, this is a transition. You'll see it in the instruction over here. It's always true is this. This is the instruction. I clicked on it here. Now what's going to happen? This is always true. That means the program will start here, come here and stay here and here. I want to put it there for now. Let's forget about these 2 steps. I'm going to stop over here. I want to stay here forever. That means I don't want to move. So this one is going to be always false. Always false. I'm going to put always false here. And that's it. Now let's start and see what's going to happen. Now, first of all, let's start here. Well, I'm going to stop this one here, minimize it or put it like that. Come over here and then work out my logic here. Now I'm going to start here and see what's going to happen. So the box comes and stops. Now I'm going to start and then this thing runs. Now let's start the sequence. So you see, yeah, 3 seconds and then back. 3 seconds back, right? So everything's working. Now I have to find a way that at the end of my cycle, I need this box to come back at the top and start trickling down over here. So I need a signal here to define for me the end of a cycle. So I need, because at the end of the cycle, I need to initialize the position to x0 position. It has to be 0 and the y position has to be 0. So somehow I have to initialize them back again to 0. So if I go back to my graph set here, I need to, reaching here at some point, get a signal for end of cycle, so it comes back and initialize these things back to their initial position. So I'm gonna come over here. I'm gonna forget about this instruction. I'm gonna create a new variable called end of cycle, or let's say I'm gonna call end of cycle. Right? The end of cycle, when I'm reaching the end of cycle, this is, I still have to find how we're gonna change this variable to make it true that this is the end of cycle, but the end of cycle here condition gonna push me here. So if I'm reaching the end of cycle, I want to come back over and start again over here. So the end of cycle here, very simple. If we come over to this diagram, if I look here, I'm gonna rely on my ladder here. You see, the end of cycle happen when? It happens when the done cycle on this timer is completed. So what I'm gonna do here, I'm gonna just increase and put here one extra line. If I go back again here to my ladder, I'm gonna take this one here, and I'm gonna say that once I'm reaching the end of the cycle, so I have to associate the done bit to this instruction. So the done bit here, it will create for me a signal which I'm calling end of cycle. So I'm gonna say here end of cycle. And from there, I will have to transfer the value of this instruction to my variable. So my variable, I called it end of cycle. This is the one I just defined here. And doing this will take care of sending the single end of cycle, right? Now, let's back again and test and see what's going to happen. Now, if I run it here and then run it here and start, so you see, I'm missing here one step, you see, but I see that the end of cycle did something to make this box move over here. Now, the way it's reacting like this is because the box, I have to start pushing the box only when it is in the right position. So I have to change again my program. Remember, I just gave a flag for the in position. So if I come over here in my sequence, this is my start button, and this is the signal going once I'm starting my cycle, sending the first solenoid signal to the solenoid. So I should not start my cycle unless this box it's in the right position. So I come over here, I'm going to change the program. I'm going to take this one, I'm going to move a little bit here to give it some space. I'm going to take here condition, and this one I'm going to associate to the in position. In position 0, this is the variable I simulated in my graph set. So I'm taking it as a condition. And from there, if I come over here, let's start again. Let's see what's going to happen. Let's see. I'm going to start my motor, and then start. Now you see, now you're talking. Now I did my sequence, which is okay. The only thing's missing now for me is this box. I see it. I see it, like when I end of cycle, I see box. I don't want to do that. I want to hide this box at this point here. I don't want to show it. I want to start showing it when it is here. So when it is here, I want to show it when I'm having the signal I'm getting the signal over here. I want to show it at this point. So what I want to do here, I'll have to come back again to my graph set. And in my graph set, I'm going to come here. I'm going to just modify it. And here I'm going to modify it here with the sequence. I'm going to put here like that. And what I'm going to do and say what I'm saying here, I'm going to, when I am the condition of IB0 here, when I'm getting this condition, I'm going to create a variable which I'm going to call is visible. This is a new variable I'm going to create here. I'm going to say is visible. And it's a Boolean. And is visible here, I'm going to give it a value of 1. I'm going to force it to 1. So I'm going to do it forcing 1. So forcing 1 here, right? And then when I'm reaching the end of the cycle, I want to put it to 0. So here, condition is going to be end of cycle. Sorry, going to be here, end of cycle here. When I'm reaching the end of cycle, I'm going to make is visible. Is visible. I want to put it equal 0. Right? And then here I'm going to move. I'm going to make it like a true. I want to go right swiftly to say it's true. We want to pass this condition. And then what I want to do here is just like, I'm going to close this one. Let's say, bring it over here. And then from here, I'm going to go and connect there. So that's basically what I want to do. So once I'm reaching the signal, I'm going to make it visible. And at the end of the cycle, I'm going to make the box disappear. So doing visibility on the box is very simple. I go back again in the drawing here. On this box here, I'm going to create a visibility animation on the box. I'm going to create a visibility animation on the box, one threshold, and then the variable is visible changed from 0 to 1. So the threshold here is going to be 0.9, means like when the value of the variable is less than 0.9, which is 0, I want to make it invisible. And when the value is greater than 0.9, which is 1, I want to make it visible, right? And here, I'm going to associate the visibility to my variable I just created, which is called isVisible. And now I should be okay. Now let's start again. So I'm going to start my motor here and then start my sequence. So you see here it's there. Now at the end of the cycle, it disappeared and then it shows back again here. And I'm almost done with, well, actually, like the other one, the remaining part of the animation is really cosmetics. So this is my animation. So let's start doing the stuff over here to complete that here. So I'm gonna stop here. Now, notice that in this system, I showed that this thing stops by a, let me zoom here a little bit. I have to create something to show you as if it's going on a piece of metal, or it's gonna just like to show that it will like come here. So I'm gonna go change my grid to grid, and then I'm gonna draw something like, okay, snapping here is just snapping to the grid. So for example, like that. Let me go half a grid to be able to make it thinner, this rectangle. And then let's say I'm going to take this rectangle here. I'm going to change it. This is cosmetics, really. So I'm going to do it like that. This is me like you're going to not go fly in the air, just like sitting on a surface, going to move on a surface, right? Now the other things in the animation, I want to just start giving some colors to this thing. So I'm going to come to the box. I'm going to say here, let's color the box. So the coloring the box, I'm going to change the fill pattern to solid and then not black. Let's say make it orange and then like that. Oh, it has a contour. Forget the outline. I don't want an outline. And let's say I want to give it some effects here. So the fill pattern, I want to make it like more to feel like a cylinder. So I'm going to make it like that. So now it's like more like a cylinder. Now we're going to do the same over here. Fill pattern solid foreground. I'm going to make it like gray, then give it some shadings and this way, and then take off the outline. So this is going to be it. And then if I want to make it even more fancy, I can just come over here and give it another kind of animation, which is a color animation. Color animation is I'm going to change the color of this box while it is moving horizontally, and I'm going to do it. Let's say I'm going to create a three-fold animation here, for example, here. So I know that it's going to be related to the value of the position. Position will vary from 0 to 10. So I can say that 2.5, 0 to 2.5, I take three values, 5 and 7.5. And then this takes care of when the value goes greater than 7.5. And this is relates to the X position. The X position changed from 0 to 10. So 0 to 2.5 is going to be this color. So I'm going to change the color. Here I'm going to start like being in this color. And this is the color of the line here. Now let's say I'm going to come over here. I'm going to, when it goes between 2.5 to 5, I'm going to turn it green. And then let's say I'm going to turn it green, and between 5 and 7.5, I can keep it blue, for example. Let's keep it blue. And then from 7.5 to this, I'm going to just turn it red. So I'm going to turn it red here. And this color animation is related to the variable X position. So you see here, X position is here is the variable. And now let's see what's going to happen. Like if I just like goes like this here, and then go in simulation mode, turn my motor and do a start. You see, just like color change over here. Now I don't see the coloring because it goes fast. So if I want to see it, I can just reduce the speed on the, so I make it like very slow. It's going to be very slow. You see, as it moves, the value change from 0 to 10, so I can see the different color I associate it to my animation. So, like it's up to you, like this is really something that you have to play around with, but just to show you that you can do it. Now you see this motion is really related to the adjustment over here. So and here you go. Now I'm here done with my project. Thank you very much for your time and have a nice weekend.